Playground after a very successful tenure where he brought it back to life post the pandemic. And the person who's been nice enough to volunteer for what is a lot of work and sadly nothing that he gets paid for is one of your presenters this evening, Barnaby. So if I could trouble you for a moment for a round of applause for both of them, because it's a huge commitment and for a very good cause. So anyway, this evening, these two gentlemen will be talking to you about Ansible. So we've got Ben and we've got Barnaby, the leader of our evening. And I hope that you really get something out of it. Thank you very much.
Definitely on, right?
Have they done me instead? You're on now, I can hear you.
Yeah, okay. Sounds weird though. Sorry. So as Andy has just introduced, this is the DevOps Playground, and we do this every month to help people get hands-on with tech and learn new technologies or build on existing skills. And today we'll be given an introductory session to Ansible by myself, Ben, and Barnaby. James, could you reduce the feedback a little bit? Yeah, thanks. So what we're going to talk about is firstly what Ansible is. We'll talk about some of the benefits, how it works, the limitations of using Ansible, and we'll summarize, and then Barnaby will take you on to do some of the lab exercises. What is Ansible? So Ansible is an open source Python-based software that uses configuration as code to enable automation and infrastructure, and this includes software provisioning, app deployment, and configuration management. So next. So this is just a short list of some of the benefits of using Ansible, and I'll go into some more detail on each one of these. So firstly, Ansible makes performing IT tasks more efficient and less time-consuming. So Ansible saves you from having to SSH or connect to multiple target servers and individually configure them. The tasks are executed on target servers from your own machine or the server on which Ansible is installed. And you use configuration files or YAML files to define what configuration you want to set up on your target servers. Ansible promotes reusability for different environments, so you can basically apply the same configuration across different sets of servers or target servers that you want to configure. And Ansible, a good thing about Ansible is that it encourages idempotence, which is basically if you want to configure something one way, every time that you run every time you run Ansible, it will produce the same results. And just to touch on how idempotence works, so Ansible actively checks the current state of your configuration. It will compare to what you've defined in your code, and if it notices any differences, then it will update your systems to reflect those changes. And this is particularly helpful and important for preventing configuration drift, where what you've defined sort of falls behind or differs to what you have on your servers, for example. So Ansible supports a wide range of infrastructure. I'm sure some of you might have used some cloud provider, AWS, GCP, or Azure. So it offers multi-cloud support and multi-OS support. And what we'll be doing afterwards at the end with Barnaby is we'll actually be configuring some virtual machines on EC2 instances, so on AWS. So Ansible is agentless. Now, with a lot of software, you might need to install an agent onto your target servers that you want to configure. However, Ansible doesn't have this requirement, which means it saves a lot of effort in the beginning when you're getting set up. So you simply just need to install Ansible on your control machine, which could be your own computer. And then Ansible will simply just SSH into those servers that you've specified and perform whatever actions that you desire. So how Ansible works, I'll run through some of these just in more detail. And we'll get a better picture of how it works. So firstly, Ansible uses YAML. And I'm pretty sure a lot of you would have used YAML configuration for maybe like a Kubernetes deployment. So YAML is quite known to many. It's easy to read, it's easy to understand, it's quite intuitive. And the YAML configuration is used to define what you want to perform in terms of creating roles, playbooks, tasks, etc., which we'll see later on. So a typical folder structure of Ansible, and it's recommended by best practices, is that you will have an inventory directory, or it could just be a file. And in there, you will define what your target servers are. Now, just below, you have, in the second green box, you have a bunch of YAML files. Now, it's not always required to separate your playbooks. So there's a database servers playbook, a web servers playbook, and a site playbook. And all of these would have a similar structure, as you can see here, which I'll go into just now. So as you can see, the sites, the web servers, these will all contain a bunch of different target hosts that you want to apply some configuration to. So to break down into what the roles are, and they allow you to load the related tasks. So you have tasks, handlers, vars, defaults. It allows you to load all of these onto Ansible. And the task itself is the smaller unit of action that you can use to configure a server. So by theory, you could literally just have one main.yaml file, and Ansible can do something, but in reality, configurations are more complex, so you might want to do slightly more configuration changes. So you have handlers. Now, handlers are commonly used to start, stop, restart, or reload, and stop services. And then you have things like defaults and vars, which are typically just your variables. The defaults take slightly less precedence over vars, and you can choose to use them. It's not mandatory. You can use vars, or you can simply just put in the values in the file, but normally you want to pass in some variables for credentials, for example. And then you have templates, which are Ginger 2 templates, so it's Python-based. And these you can use to create files, for example, where you pass in values like from variables and stuff you might want to load onto one of your servers. So a good thing about Ansible is that it provides you with a wide range of modules that you can use to do common tasks, such as installing a server or installing some packages, updating packages. And these get sent from your control machine over to the target servers to do their jobs. So as you can see here, we have a list of some things that you could do. We have like create a user, start a container, copy files, create files. So there's a lot you can do. And it's worth noting that if a module is not available, then you could create one yourself. However, that can be a bit complicated. So here we have an example of a playbook/task file. Because remember I said that you can literally just have one file that would define all your configuration. But we tend to put them into playbooks, which will break down the execution of tasks. So every task would have a name. This simply is describing what the task is going to do. And normally you want to keep this very descriptive and concise, and we'll see why in a second. You have the host. The host defines what the target server is. So we want to run some configuration on the web server's host, for example. And then you have remote user, which specifies what user to use when you're running these commands. And then an example of a module that we are using here is the ansible.builtin.yum. So that's the yum package manager, which you can use to run yum commands. So here we have an example execution, and Ansible will execute each task one by one. And it will execute it against all the machines that you specify. So sometimes you'll run against all hosts, or you'll run against a specific set of hosts, like maybe a web server or database server. And if we were to run the play from the previous slide, for example, we might see something like this, where you have the tasks. Remember I said that the names are very important because this is the feedback that you get. And then you have the host where it says what it's running on. You have different task statuses. So green's okay, yellow means something has changed. Red is always bad, so something's failed, obviously. And then you have things like skipped, where, for example, it doesn't match the host that you've specified, so it's not going to do anything. And then at the end, you get a player recap, which is a summary of all the changes that have taken place, basically. So if you're interested, behind the scenes, what Ansible really does, and I've mentioned that it's Python-based, it will take the scripts or the YAML configuration and create Python scripts, send that over to the target server, and execute it there over the SSH connection. Some of the limitations of using Ansible is that unlike tools like Puppet and Chef, Ansible doesn't have intrinsic state tracking. So Ansible simply executes the tasks and stops when all tasks finish, fails, or an error comes about. So whilst this might benefit smaller tasks, it may not be ideal for more complex configurations where dependencies and idempotency are crucial. So without built-in state management, state tracking, debugging errors can prove to be difficult, as you'll have to go analyze the playbooks and understand what task ordering is going on and pinpoint any issues. Ansible has limited Windows support. So things like functionalities may be limited. Ansible may not support certain features. You have potential scaling issues. And as previously mentioned, it's good for smaller setups, so it may struggle with larger setups, especially when manipulating a lot of data, for example. And scaling can potentially be managed by using dynamic inventories, where you dynamically load or dynamically set the hosts or target servers you want to use and parallelizing tasks. But this can be quite complicated to do. And then you have things like security considerations, right? You want to ensure that any credentials that you're passing in through Ansible are not being made vulnerable or read by unintended parties, or you don't want to commit it, for example. So there are ways around it, as always. And then the last one I have here is it's got limited experience in large enterprises. So I did mention that Puppet and Chef are probably more established with large-scale enterprises. So Ansible's suitability for complex IT environments could be challenged in a sense. And to summarize quickly, Ansible is an open source provisioning and managing infrastructure tool. You use configuration management to define what actions or configuration you want to execute onto your servers. You use playbooks to design the desired states that you'd like to execute on the target systems. There's lots of modules that are available for you to use for things such as installing packages or setting up users or running Docker containers. And finally, it is not as mature as some of the tools as we've just seen. And also there's limited Windows support. So I think that's it from me. Barnaby here is going to take you through some of the labs, but if you have any questions, then please feel free to raise your hand. I think there's a catch box that we can use because there's also an online audience. Don't trip on this.
Hello?
Go ahead.
Is it possible to do Ansible job with Terraform?
Yes.
Yeah, I can
Go
answer
ahead.
it.
Yeah.
Depends what you. They don't really work together. They do slightly different things. You could often what you do, you'd get Terraform to build your infrastructure, and then once your infrastructure is built, you'd use that to trigger an Ansible deployment on that infrastructure. You wouldn't use Terraform to run Ansible in that way.
No, I mean, they have SSH module in Terraform, and usually, like, people use bundle of Terraform and Ansible in the infrastructure repository. So I was curious, is it possible to use just one tool for the whole infrastructure as code?
You can do. I've seen people, well, the way you do it with Terraform, you do it with providers. You can't really use Ansible to create your infrastructure to an extent, because you can build your own modules, which you can get to execute any Python scripts that you want. So you could do it. I wouldn't recommend doing it, but you could, in theory, put Ansible into an SSH module. Although it wouldn't trigger through the SSH module. It needs to run through, because it's a Python-based package, and Python handles all the connections. It doesn't do it over raw SSH. It's within Python.
Yeah, I suppose what you could do, I mean, this is probably not what you're looking for in an answer, but Terraform can provision the virtual machines that you want to run Ansible on. So you could set it up that way, but to an extent, they don't really work together like that. Yeah.
Okay, that's it.
I think we're just putting some batteries in the mic, and it's going to come back out.
Sorry.
Is there any specific clouds, like we have Azure, GCP, AWS, right?
Mm-hmm.
So Ansible make more sense for which cloud? Is it like agnostic to all these three, or which cloud service provider uses Ansible a lot?
So you can use Ansible with any cloud. I think basically what the cloud providers do is they give you access to virtual machines. So Ansible can connect to bare metal servers or virtual machines, and all cloud providers provide their version of a virtual machine. Now, cloud providers like AWS, I know they have a way of managing their own EC2 instances, like installing stuff on a batch of EC2 instances. So you may not necessarily want to use non-native tools like Ansible. So there are native alternatives that you can also use in the cloud.
Okay.
I guess another thing with the big cloud providers is they're more likely to have a dynamic inventory system set up for you. So instead of having to define the IP addresses of the host you're connecting to, you'll be able to interface with the cloud CLI and pull your hosts into Ansible based on the tags that you give those instances in the cloud. So the major clouds all support this.
Okay.
I don't know what the support is on some of the fringe clouds, so they haven't gone that far into sort of the cloud ecosystem.
Okay. One last question. You mentioned in your slide that it's lack of Windows support. What does that mean? Like, is it like Windows operating system installing again? Or?
Yeah. I don't know too much into using Ansible on Windows. However, Ansible, from what I've read, Ansible doesn't support many of the functions or functionalities that you might get with Linux or Linux, Ubuntu, these operating systems. So you might still be able to do what you want to do on Windows. It might just be a little more challenging, or you might find there are some limitations.
Do you have a question down the front?
In the front.
Colin?
So you mentioned it runs on Python.
Mm-hmm.
Does that mean Python has to be installed on the target server, or does it only run on the computer where you're running Ansible?
You will need it on the target server as well, because it executes the scripts that it creates on that server. So if it doesn't have Python installed, it will fail to execute.
Okay.
Yeah.
Is it reliant on any particular version of Python? Sorry.
Depends which version of Ansible you build. The older ones use 2, the newer ones use 3. So you can support both depending on your estate.
Back to Terraform. So Terraform is a tool designed for cloud infrastructure provisioning, but you can do the same thing with Ansible, right? But what is more convenient?
So Terraform is for infrastructure as code. It's what that's designed for predominantly. So it's spinning up and creating infrastructure. Ansible is aimed at configuration as code, so it's more for configuring applications and setting config files and stuff like that on the servers.
Yeah.
So you would be less likely to create infrastructure with Ansible, or in the same way you should be less likely to configure your applications using Terraform. You can do both, but it's not really what they're designed for. So with the provisioners block in Terraform, often what it does is it just runs that command on the server. It doesn't check to see if the desired state's already there, whereas Ansible, so it will check to see if the output of the command is already the state of the server, and if it's already the state, it won't run the command. So you have less interactions with your server using something like Ansible because it checks the kind of the output, whereas Terraform, when it's doing configuration, doesn't have that same level of knowledge or the same ability to check the state of the application config.
Okay, and the second question is there a tool, infrastructure as code, that supports Windows better than Ansible?
I'm not sure. I think you might get better mileage with potentially Puppet would do it.
And why so?
I think they just have a more advanced Windows infrastructure than Ansible. They're sort of they built kind of more and larger enterprises. They cater to that market, and that market tends to be more likely to run in Windows, so they have a higher level of support of it. Ansible is owned by Red Hat, so it's built for the Linux distros first, and then it's kind of expanded out into Windows. So you can still run it on Windows, but you may have to put in a bit more legwork around some of the modules and some of the configuration to get it working.
Okay. The third question, would you use Ansible as a make file thing to automate some local host tasks?
You can do. It depends. So you can get it to run makefiles, you can get it to execute things. You'd essentially use it for your initial setup. A lot of it is what you do. You build config files, set up service files, or stuff like that, make sure services are enabled, and then have your application in a running state, where kind of a blank running state, and then after it you'd go into the application configure. So using it for make would be a sensible use case, but it's kind of designed to pull in pre-made binaries a little bit more, rather than building the application. It's for configuring it, so it'd pull a binary in and then set up the config for that to run in an environment.
Yeah, I've just seen some people using Ansible instead of Docker Compose, for example, so they can pull a Docker module and set up all containers using Ansible playbooks. Okay, that's it. Thank you.
How easy is it to use Ansible in a GitHub or GitOps type environment?
It's pretty easy.
Fairly simple. You just need somewhere you can execute Python code, essentially. So if you have a GitOps environment where you have some runners that can run with a Docker container that has Python in it, install Ansible into that container as well. You can run Ansible as long as you have the network connectivity to reach your hosts over SSH.
Yeah.
Hold on, one more question.
Have you heard about, what's the name? The GUI application, web interface that can run Ansible playbooks. Is there any solution to that? Can you create some playbooks, for example, for your QA testers to run some CI/CD and give them access to this web panel there? They can execute these playbooks.
So the enterprise solution that Ansible offers, they only offer this kind of at an enterprise level. It's called Ansible Tower, where you have a central sort of job template and you can manage access to jobs and roles in there. You can delegate certain roles to certain teams. So you could set up a web test role that checks everything's happy on your web application server and delegate that job to your web application team, and they can run it to run the checks. But that's through an enterprise solution, not the open source offering. So if you want those functionalities, you just get the enterprise license, or build it into your CI/CD yourself. So build a CI/CD pipeline that just runs the web application playbook, and then give your developers access to that.
There's always rundeck, all written in Java.
It's Python based. It's not.
It's what?
Python.
Python based, not Java.
Yeah, but you can run playbooks with rundeck. It's open source solution. If anybody wants to know.
Oh, okay. No, I didn't know that. Thanks.
Ready for a lab? Is that good? Right.
Yeah, I'll let you do it. I'll also be around if you need help during the labs, but I'll let Barnaby do his thing.
.org, you should be able to get access to the lab. I will just need to adjust my screens and I can show you what this looks like. So let me grab. So you should be, when I get the projector back, have I lost it from the laptop?
There you go. You sent it back to me.
Sorry. Yeah, you should get something like this. Enter your meetup username. So mine's Barnaby. And you'll be returned with a set of links. So you'll have your username for your instance, the password to log into your instance. You'll have your IDE. So this is an instance of Visual Studio, which has all the code in that we'll be using as a base. Some of this has already been set up for you to try and reduce the amount of copying and pasting we do. On here, you'll also have a Weti terminal. So this is essentially an SSH session into your workbox. So for this, we will need our password. So put that in there. Just old habit from workplace. If you just cat a session, it will keep it alive for you instead of logging you out. And then the final link is a link to our the GitHub repo for this, which has the README in, which we'll be following. I'll set this up so I can run it beside, so you can see both, hopefully. So in theory, everything we need should be in this README. If anyone's having issues connecting, please let me know, and one of the volunteers from the back will be out to help. Yeah. Does anyone else need Wi-Fi passwords before we get going?
URL.
labs.devopsplayground.org. Let me see if I think I still have it up. So labs.devopsplayground.org. All right, are we all good? Okay, so let's get going. So we have our README here, and this should have all the information for you to complete the lab if you don't quite keep up with me, or if you wanted to go back and do this at another point, you would have to create your own infrastructure, but the information is all in here. So the first step to setting up Ansible, we need to define our inventory. And we have an inventory file here. It's not complete at the moment. There's a few bits missing. So we've populated some of this, and we've populated it in a way that will be useful later. So the top level object we have is this is for all of our servers to live within here. And then under that we have children. So we want to define groups, subgroups of our parent group to potentially tell Ansible to do different things to different servers. So we have our console servers, and we have our console clients. In this lab, we're going to be configuring console. Is a good level of complexity for a lab. There's not particularly another reason why we chose this, but you also get to learn how to set up a console server as a sort of aside of learning Ansible. We have the IPs here, which are currently 0.0.0. We will need to update these with the actual IPs of our hosts, and this should be in a file on our server. So let me just check where it is. So I believe it's in our workdar. It's target instance.txt. Am I just being blind? Yeah, target instance.txt in here. So if we cat this, we should get our two servers. So in this lab, we have the server that we're running Ansible from, and we also have a second server which we're going to be configuring remotely as part of this lab. So we want to take these IP addresses and we want to populate our inventory file. So we're going to set our console server to be our target instance, as we don't want console running from this server, but we're happy for it to be a client. And then we will take our IP of the VM we're running on, and we will add it to our console clients group. And the last thing we want to populate in here is our SSH password and our sudo password. If we were using SSH keys, you wouldn't need your SSH password, as the key would do the authentication. As this lab has been set up to be done over the public internet and open, we're using passwords. We would not recommend this for sort of doing this in production services, but as it's a short lab and everything's going to get destroyed afterwards, it doesn't really matter. That password is here. It's Ansible, and it's going to be the same for both. So we need to populate that in all 4 of these instances. Let me make sure I copy correctly, and we should be good. Someday I'll learn all the fancy tricks in VS Code, but at some point, it's a bit of time that I haven't invested but would be worthwhile. You don't need to tab this out. This is just my own little bit of OCD to try and get the colons in the same line. So this, in theory, is all we need for our inventory file. And there's a way we can test that this is working by running this command here. So if you click the little boxes, you should get a little copied. Go back to our Wetty terminal. We need to cd into the folder with everything in. So that's our Untitled Playground, and then we can run this to see if it's working. Unfortunately, it is not. So it's saying we're using a SSH password and enabled does not support this. Please check the host fingerprints. This is an SSH error. We essentially don't know what box we're working on. If you were doing this through dynamic inventory or you set up your SSH keys before, or this would work neatly. What we have to solve this problem, though, is there was a little script in your home directory which will create our known hosts file for you. So if we run this, // and then we do add hosts, that should add the host to our known host file. So now, if I go back to my Ansible inventory in our workdar and Ansible Playground, run this command again, we now have our Pong response. So what this command is doing is we're telling Ansible to execute a command directly, in this case ping. Ping in Ansible doesn't work like your standard ping. It's not just sending an IMCP packet to the server and getting a response. It is SSHing to that server and essentially echoing the word Pong on that server just to test that the connection works. So this is what we're seeing here. So now we can connect to our server, and you should get the little response here. We've got some warnings where it's not happy about something, but we'll ignore those for now. So we've now got our inventory. We want to start setting up our playbooks. So the first thing we want to do is some base level setup that's not related to our application, but things we'll need in the process of setting up. So for this, we need unzip, because we'll be downloading binaries off the internet and unpacking them. We will need to decompress those. So let's go into our coder again. We don't need to have inventory open. We want to go into roles. We want to go into base, and then we should automatically get into tasks. There's no more folder structures in here, and we want to go into our main.yaml. And we want to add this task here. This is YAML, so be careful with your indentation. The copied blocks should be indented correctly, but sometimes copying, pasting doesn't always keep the formatting right. So we've got our first task here. We've given it a name, which is called installed required packages. In this case, we're only installing one. The package section is the module that we're using, so it's our packages module, which handles packages on Linux distros. We're giving it the name of the package that we want to be installed and the state of that package. So this state, it is present, and that is all the information Ansible needs to install that on our servers. We've created this. We now need to put it in a place where we can run it. So we've set up a role, but we haven't set up a playbook. So the playbook we're going to be modifying today is main.yaml. You can see we already have a role in here. We're going to try and do some test-driven development. So we've written some health checks for our service. That will run at the end. As the lab progresses, hopefully more of them will pass. So before that, we want to set up the things we need to install. So we put in our role. This should match our name here. So you see base equals base. We're giving it a name of the overall thing. We can have multiple roles here. We tell it the hosts we want. In this case, we want this to apply to all of our servers. And we also have become true. This is essentially telling Ansible that we want to elevate to root to run these commands, as they can't be run with the user that we're logging into, which in this case is Ansible. So we're going to elevate our permissions to root to run the commands in this role.
Why do we have specifically to elevate to root? Can't we SU or give a build group to a user? Because it's quite, to elevate to root has a lot of implications downstream. If it is the user is given some privilege, like a wheeled group.
This become doesn't have to be root. So this become can be any user you want, and you can set up your Linux permissions to give that user the appropriate permissions to do those tasks. In this case, for a demo, it's easier to go to root, as we didn't see the need to set up all those permissions, as this is very short-lived infrastructure that will be destroyed. If you're doing this in your own sort of production environment, then yes, set up your users in an appropriate manner, and then you SU to your user that has the right level of permissions and use that for your installs. But in this case, root has enough privileges for us to do it, and we don't need to get into a full Linux RBAC setup. So we'll just be going to root for our elevation. You can elevate to other users if that is your use case. So we've now got a play in our playbook. We are going to start messing around with some of the console config. So we're going to go into a different role this time. We're going into our console comment, and we're going into our tasks, and we have another empty tasks YAML here, which we want to populate. So the first thing we want to do is we want to create a console group. So here you can see a similar structure to the last task we defined. We give it a name, which is create console group, and this time we're using the group module, so we're creating groups and the name of the group. In this case, we're using a variable because we will probably want to use this group elsewhere. These variables can live in a couple of places, as we mentioned during the presentation. So you have the vars directory within the role itself. This one doesn't actually have the user in, because in this case, it lives in our group vars for our project. The names of these YAMLs correspond to the groups in your inventories files. So this one is corresponding to all. And you can see we have our console group, which is also a variable, which is the console user, as can be the same. This group vars has been populated for everyone beforehand, as these will be common things that you'll need to pull throughout the playbook, and it's easier to have them pre-populated to avoid any issues with wrong names and stuff. So this is where these live. And let's go back to our task and start setting it up. So we've got our group. Now we want a user. And we just want to paste this under our group. And I didn't copy. So there we go. It's just create console user. Almost exactly the same, except we're using a different module, which is user in this case, instead of group. And the final one that we're going to set up in this for now is we're going to start creating some directories for console to use. So in this one, we're using our file option, which allows us to create directories. So we give it the path. In this case, we have item as our variable. The state is directory. Yeah, and then we have owner console and group console. Probably should have changed those to be the variables we set up there, but never mind for now. We're also giving it a mode that we want on these, as these should be only accessible to the console. And then we're using a new block, which we haven't seen in any of the previous plays, which is with items. So this essentially means you'll run the play again with each of the items in the list, and that will fill out the item part of the section. So, in this case, we're going to create 4 directories for console. Some of them are hard-coded, some of them are taken from variables, and this will create all of them in one block. So if we're doing similar tasks, we can group them together with sort of a with items block, like so. So now that's kind of the base of what we want for our common. We need to add that to our main playbook. In this case, we can just add it to our console base, as we don't need to do it in a different play. So this will run the roll sequentially. Occasionally you want to separate plays because you'll need something to have finished in the previous roll before the next play can start. So in this case, we don't need that to happen, so we can run them sequentially. Right, let's test out our code and see how well we've done so far. So we go back to our wetty, and we put in this command, which is Ansible playbook. We're giving it our inventory, and we're giving it our playbook. Let's see what happens. So first, we're gathering facts, which is pulling information about the server, and we can see we're starting to change stuff. So some of them are OK, some of them are yellow, which means they've changed, and now we've failed. So we failed when we got to the health checks. So the particular one is saying console service does not exist. Kind of makes sense. We haven't really done anything with console so far. The things we've changed is we've created our user and our group up above, and we've also created all of our directories. And something that's quite nice to see, if I run this command again, and we should see a lot less yellow because the servers are already in the state that we want. So we don't need to run those commands again. So you can see we just have a wall of green, and we'll eventually hit the same error, as we haven't done anything differently to what we've done before. The state's still the same, so the service still doesn't exist. So that's the part 1 or part 2. So let's move on, and we will start building out the things we need to get this service up and running. So the first thing we want to do is we want to actually get the console binary. So we're going to use a different module, and we're going to pull our binary. So let's go back to our coda. We're still working in console common for now. Under main, we've set up our directories. We now want to download our console binary. So we're using the get URL. We're giving it our URL, which is releases.hashscript.com console. And then we have the version that we want to pull set as a variable, which means if we ever want to update the version that we're running later on, we go to our vars file, change one number, and it's applied throughout the playbook, and it'll be applied to any servers that we run this against, meaning it's very simple, easy to do, but if we don't change that number, it will go, it's the same version we already got, we don't need to change anything. It's downloading it to a temp file, as we will just unzip it from temp, and then it can be removed, so that's totally fine. We have it, so we've got it downloaded, now we need to unzip. So new module, we're tailoring it to unarchive. This is why we needed to install unzip, because we use unzip to unarchive this. We're giving it the source of our zip file, and then we're giving the destination that we want it to be unpacked to. We also have to specify, in this case, remote source. This module will look for the packages on the local host that you're running Ansible from, and then copy them over if you don't specify this. Specifying remote source is saying what I want to unzip is already on the server that I'm working on, take it from there instead of copying it up for me. So we've added this. We can now test that it's working before we move on to part 2. So if we just run the same command that we were running earlier, this is going to be the command that we run for the rest of this lab to test it. So you can just use your git history or your bash history to pull it up. And we should see a few more things populate in here. So we've seen we're downloading the binary, we're expanding it, and we should still fail where we did before. But hopefully, if I type console now, we now have console installed. I could have been lying to you and installed it earlier, but you saw it change, so it's definitely gone to the right path. Anyway, so we've got console installed. We now want to set up a service file so it can run automatically, and we can start passing some of these health checks I've set up to actually do something. So, part 4, we're going to look at templating and how that affects. So we're still working in our common file. We want to copy these blocks and paste them in. So we're setting up a service file, and we're starting the service. So we're giving it a source, which is console service.j2, which is our template file. In this case, it lives in here. So we have a couple of templates here, console service.j2. And then the other block we're giving it here is a service block, which is saying we want our console service to be started, and it should be called console.service. Yes. So we now need to populate our service file. Currently, it is empty. So this is our next block here. This is our unit file, which is a Ginger2 template. We're not doing a huge amount of templating here. We're passing it the config directory, so if we ever wanted to move where console resides, we can just update a variable, and everything will move, and your config will continue to work. You may lose data if your data is stored in your config directory, but you can port where your service lives fairly easily just by updating one variable. And we give it again here in our exec start, we're telling it to look for that same directory. So it mentions a config directory. We probably actually need some configuration for this. So let's create this, and this should be done above where we created our service file. As in the service file, it checks to see if this exists, so we should be creating this beforehand. So similar block for before, we have template, giving it a different source and a different destination this time. And we now need to fill out a different config file. There's some slightly funkier stuff going on in this template, which I'll go through. So the top bit here, it's querying some of the information within Ansible about its groups, and it's picking out any server that is a host or that's going to be a console server for this particular setup, and it's adding it to a list and joining those together. So we can increase the numbers of console servers in our inventory file, and our config files will dynamically reflect that when we run Ansible again. It will change the retry join block, so they'll join together. And then we're also pulling some information about the server in using our IPv4 address. The other thing that we have in here is an encryption key, which is currently hard-coded, which is not best practice, but this is just a base 64 encryption key. And this is a demo, so take it as you will. Don't use this particular key elsewhere, as it's now been shared online. Okay, so we have a couple of other tasks that we've set up for you that do similar things. They're more templating. They're just specific to certain hosts. So we have our console client task, which is just another template block, and in this case, our template has been set up for you. Here it's just pulling some more information about that's relevant for console. And I thought it would save you some copying and pasting by setting these up as well. The other one that is in a similar vein is our console server, which does the same thing, but for our servers. So we have those extra tasks that set up our config. We now need to put them into our playbook. And when we do this, we'll see we are setting this up to target ever so slightly differently. So make sure your health checks are still at the end of your playbook, as they should run last. But we want to set up some server stuff and some client stuff. So you can see here, instead of all on my hosts, I have console servers and console clients. These are pulled from that inventory file that we set up at the very beginning. You have console servers, console clients. This allows us to separate servers into different groups to apply different things to them. So we now have a few more things in our playbook. Let's see if we get any further in our health checks. And I have got a YAML indenting error somewhere. As I told you all to be careful with templating, I didn't check it your indentation, I didn't check it myself. So in this particular block here, these two look like their templating is off. So if you just tab those in one, and if you make sure you're using 2 spaces to indent, that should fix that. And let's try again, see if it's happy now.
Which one was that?
Console common, the last 2 tasks are indented slightly wrong by the looks of things. So the ones that are setting up the service file and enabling it, the indentation isn't quite right. The ones we did at step 1 of part 4. So just tab the blocks in under name a little bit further. So we've gone further. The console service does exist now, but it's not running. So progress, not a successful option, but you can see we're getting down in the list. So next thing, before we start messing around more with our config, we're going to introduce the concept of handlers. So the way handlers work is you append them. They live in a separate block, and then you notify them when they're needed. So if there's a step that needs you to restart the service, you'll restart that handler. You'll trigger that restart handler. The idea behind this is you may have several plays in a playbook that need a restart of the service, but that service doesn't necessarily need to be restarted instantly. So you send a notification to this handler. Once that role's finished, it goes, okay, at some point in this, a configuration change happened that needed a restart. We've finished all the configuration changes in this role. I'm now going to restart the service. So it gives you a more elegant way to do it. It also means you don't have a hard-coded restart block anywhere in your play. So if you know a particular task needs a restart, if that task doesn't actually apply because it's already in the right configuration, you don't want to have to restart your service every time because it's disruptive. So that's another benefit of handlers. So let's start adding these in. So in our console common again, we're moving to a slightly different directory. Instead of being in the task directory, we're moving to our handlers directory. So we have another main.yaml. Everything's called main.yaml pretty much in this. It's the folder structure that determines where they live. So we want to give it this block. This has gone too far this time. So we're telling it to restart the service. So we're using the same service module that we used for our started service to enable it and set it up to begin with, but in this time we're telling it our desired state is restarted. So whenever this play runs, it will set the service state to restarted. So this can't be idempotent because your service won't be in a restarted state when you find it. So we set this up. The name in here is important. So this will be what you use to call it in your other plays. So we will see that here. We need to add this notify statement to a few of our plays because there's a few of them that actually warrant a restart. So we copy this line. We go back to our tasks YAML. And then here are the ones we want to actually update or cause a restart on. So we have it on our expand. We want it. This should be indentated right, but it essentially should live at the same level as the module. So it's not a subcategory of the module, it's a subcategory of the task. So it will live at that level, so you want to notify there. We also want one for a create common config file. As if our config file changes, we will want to restart our service to pick up those changes. And also we want one under our service file. So that is all of the ones we want in here. We've set up the handlers again for you in the other two plays with the console server has its handler. It's the exact same one, but we haven't added the notify blocks for you yet, so we need to add those to these as well. So again, same indentation as the template block, so we want it in our console server, and we also want it in our console client, wants a notify block as well. And that is our setup for our notifiers. So let's give it a restart and see if we notice anything. In this case, we probably won't because we actually haven't changed anything in our config. So the run should be the same as our last run from our idempotency's point of view. So we don't actually need to trigger any of the handlers, although our console service is crashed, so it will try and start the service. but you can see we're moving on to the next role, and if you look at your logs, you won't see any handlers. They come out under a different, so you have tasks, you have plays, you'd see a handler block, and you'd see your handler come up under there. And it's still the same error message as we haven't changed anything. So I mentioned that encryption key that was a bit insecure earlier. Let's go about fixing that first before we do the final step and get console up and running. So we want to create an encryption key. Ideally, we'd have another system to store it in. As this is a lab, we just have these two servers, so we're going to store it on the server in a file that's just accessible to the user that should be running console for now. Realistically, you'd store it somewhere elsewhere and pull it in through a URI or a different plugin. You can maybe interface with something like Vault to pull the data from there. But we want to add these to our console common. These are going to go kind of slightly in the middle of the place. Let me just shrink down some of the stuff I don't need. We won't be going, actually we will be going back into templates, but we won't be going back into our handlers. So we want to do this before the create. We can do it before the create directories from console. We essentially want this before this binary. So as long as it's before the template that is going to use it, it doesn't really matter. I'll put it in after our directories. So we're looking to see if an encryption key file exists. So if we've generated it before, because we're running this as not using a module or a standard module, we're actually going to use commands to generate this. So if a module doesn't exist, you don't want to create one, you can just execute shell commands on your machine using Ansible. So we're going to use shell commands to create a file, so we don't have quite the same level of idempotency that we had before. So we're going to check to see if that file exists. Yes. Hmm? Oh, 54, am I messing up more indentation? Thank you. Okay, so we've now got it to check our encryption key. Ready to see if it's already been created. So let's go about creating this. So this is our shell module. So this is essentially executing a shell script. We're giving it the command we want, which in this case is console keygen, where it's going to generate that encryption key for it. We're registering the output of this command into an Ansible variable to be used in later plays. And then we have a when block. We have a when block in the one earlier as well. So this is new. We haven't seen this before. This is essentially limiting it to run on certain hosts that meet these conditions. If they don't meet these conditions, this play won't run. So the conditions we have is console servers in group names. So each host has the names of all the groups that it's in attached to it that you can query. This is essentially saying if this server is not in the console servers group, don't run this play. Okay. So that is what that's ensuring.
Doesn't that block need to happen after install console?
After install console? Yeah, that is a good point. It wouldn't matter on this because console's already installed, but this should be after install console. Yeah, so here, if we're running this clean. So yeah, this is going to run when the previous play didn't point out that the file was present, and it's a console server, as we want this to be stored centrally on one of our servers, not our client. The final path of this play is run once. We only want one encryption key, as it needs to be the same across all the servers. We don't want it to be different on each other's, otherwise they won't be able to talk to each other. In this case, we only have one server, so it's not a problem, but this is tried to be set up in a way that you could expand it to a multi-server setup. So we're going to get it to run on one server, and when you run it on once, it registers that fact for all of the other servers, so we can then populate it elsewhere. And the next thing we want to do is set up that file. So we're now storing the output of our previous play into a file using our copy module. Our content is from our console encryption key.standardout. So that's the previous play, and the register variable name we set up here. We give it a destination file, which is the same as we checked for earlier. We're setting the mode to try and be a little bit more secure, so it's only readable by root and writable by root, as nothing else should really have access to this, as it's only needed for the configuration. And then we have the same when condition as we did previously to generate it, as it should be living on the server. So because we may generate it, we may not generate it at a particular time, depending on it's already been generated, we want to cat the contents of this file into a variable to ensure that every time we run, we get the contents of the encryption key to put into our config file. So this is running a shell command again. It's catting the contents of that file, which will just be an encryption key, registering it into our encryption key variable, which we can then use in our templating. So to do that in our templating, we want to replace our old encryption key, which was hard-coded, with our new one. So if we go to our console common config, we can take this line and replace it with this. So we now have our console encryption key.standard out. So we'll take that variable we generated, and it will populate it here. So now we've got dynamically generated encryption keys, a little bit more secure. And you can see how we're using commands to run particular command blocks on the servers that aren't supported by modules. So we're using shell, and we're running pure console commands. So let's run this and see how we get along. See if I got all my indentation right this time. Console keygen, that's a new one. And command not found. So it's not happy about keygen. Let's see. So it's happy on this server. Let's see if we're happy on the other server. This all went so well when we practiced earlier, but you do it live and it never works. So this is the our other server that we set up, and I want to run console keygen here to see if I can actually run it. So that is running. It should be picking up. Let's exit out of here. I'll just double check, because it's running as root, that it is in root's path. Bash console cannot be found. That is weird. Where are we unpacking it to? So we have expanded the binary, we expanded it to user local bin, and then that must not be in root's path. So I'm going to do a little hacky way around this for now. If we had longer look at putting it into the path, but we can just give it the direct path in the command. So if we go user, because of the way Ansible works, you can't use the bash RC of a user, unfortunately, as it's all run through Python scripts that don't have access to it. So we need to do it. It needs to be in the path. So let's see if it's now happy, if I give it the full path. There we go. So for those of you that maybe didn't track what I did there, in our command where we're running it on, for some reason on our secondary server, the console binary is not in the root user's path. So instead of messing around trying to figure out what's going on there, just for now to carry on with the lab, just giving it the direct path to the binary so it doesn't have to use its own path. So if you just use user local bin, which is where we unpack it to in front of your console command, it will generate that keygen, and this may make the next one a little bit more of a pain. But you can see we had a few changes is where it set up that file. And you can see in this one, we only have one host because it's run once. And we have one where it skipped, and that's where it was looking for one that wasn't a server. So that's our client. It didn't meet our when's condition, so Ansible goes, I don't need to run that task on this, and skipped along. Okay. Final step. We should, at the end of this, hopefully we'll pass all the health checks, and we should be up and running. So we've done, the reason why console is failing is because it wants to talk with TLS certificates to its other members, and we haven't given it any TLS certificates. So we are now going to start setting up the TLS certificates. So we're no longer going to be in console common. We're going to go into console TLS. You can see we have a handler here ready for you to go as well. Let's go into tasks and start adding some blocks. The first thing actually we need to do is we want to add it to the playbook, which is here. So under our server and clients, we now want to add our TLS block. So this is to be run on all, and it passes TLS certificates between the servers. And so that's why it needs to run on all of them. As certain bits we run on certain ones. So let's create our TLS directories. Use where we want to store our certificates. Put that in here. Again, this is very similar to the ones we saw earlier. It's just pulling our TLS directories and using our console user and group. Oh, it's just using user twice because the group's the same. To create our directories where this is going to be living. And the next thing we want to do is we want to initialize our CA. We may need to come back to this and do the same thing that we did with the keygen task as it's running on the same server. So we'll give it a go and kind of with the blind hope, but we may need to come back and modify a couple of these if that path, as that path doesn't seem to be happy. So the CA in this case is a console CA. It can be its own certificate authority in this case. So we're just running the command. So in this case, we're using the command block instead of the shell, and we're using console TLS CA create, and that will generate some files. So the neat bit in here is we can pass the creates argument to this and tell it what file it's going to create as part of running this command. And this means when it goes back to run it again, it will see if that file is present. If it is, it goes, I've already run this command previously. I don't need to do it again. So this is a nice way to build idempotency into your command-based plays where you don't necessarily have it built in the module. The change jar is just the directory that we want to execute the command in. And then again, we have our run once, as we only want to create one certificate authority, and we only want it to be on one of our console servers. And if we create a new certificate authority, we'll want to restart the service as it's got new TLS information. So now that we've got a CA, we can create the certs. There's quite a few plays in this block, but they do similar kind of things. So we're going to generate server certs, and then we're going to modify the permissions on one of the cert files to ensure only the processes that need it get access to it. And then we're going to generate certificates for our clients. Again, these are just run using command blocks, and they're all run on the server because they need to be run where that CA is present. So we can see here we're modifying our permissions, and we're using the variables we had and specifying our files like we had before. So these all work in a fairly similar way. So now we have all of our certificates, but they are only on our server and not on our client. So we want to move these across to our client. The way we're going to do that in this case is we're going to bundle them up and zip it, copy that zip into a Ansible variable, paste it into a file on our client, and then unzip it there. If you're using a central solution, you would potentially push these certificates up to a safe place to store them, so you had a reference for future runs. We don't have our sort of outside state in this case, so everything's having to be passed around locally. So you can see we have our onArchive module, which we used before, or we have our archive module that's taking our files that we want to zip. We then cat the contents of that file, which is a little bit weird, but it's just a way to register the bytes in it. It's not, we don't need to read the output, so it doesn't matter that it's a zip file. It can be long and horrible. Ansible just puts it in a variable, and that's all we care about it. Then we have our copy block, which takes the contents of that cat and writes it to a file. And in this case, we're using our console clients to define our host groups, to pick the client servers, and then we're unzipping it on those servers and notifying, again, the service when we pull new certificates in. So let's see if this works. It very well may break for the same reason that the console keygen broke, but we can cross our fingers and hope. So same issue that we had before, no such file or directory. So console TLS create, so we will need to pass that path in. Again, so if we go back to our common, our tasks, and we grab our user local bin, we just want to prefix any command with that in here. So the first one we have is initialize CA. Then we have generate server certs, and the final one we have is generate client certs. The rest of this is just Ansible stuff, so it doesn't need that path. So update it in those 3 locations, and then we should be good to go. I don't think I quite pointed it out, but in some of the, let's see if I can find it in the logs where we look through, when we changed our encryption key here, what is it? This is common config file. So this has changed. We should have seen, where was it? That enable console service, config. Just trying to find where, so that was the fail of the encryption key. So here's where it's created. And as this updated our config file, it then triggered the handler. So you can see in this particular play, we have our handler run because we updated the config file, whereas in the other ones, we didn't have it running. Let's go check on that one. So we have a sort of success. We failed on one, but we passed on the other. So this is we've hit the console API to see if it's up, and this is the output of its server health, and it's saying passing. We have failed to unzip, as it is trying to retest this on a different version of Linux, and it's trying to use gtar this time instead of unzip, or it's using one, so it's failed to unzip. So our client won't be up in this case, but our server is up. So if we go to this address, we should now be able to see console. The default console port is 8500. There you go, console up and running. So that's kind of a demo of Ansible and how it works. Does anyone have any questions about how the lab went?
What did it, console itself came with the GNU zip.
Sorry?
Package, the zip,
Yeah.
Did you go around unzipping that package using standard Unix zip? How did you go around unzipping it, unpacking the...
Yeah, so it's interesting that one of the zips has failed. So we've failed this unzip, but we succeeded with our other one. I think we use unarchive here. Let me check what we use in the other one. So we use unarchive here. It may just be trying, because I think the compression creates a tar file instead of a zip file. It's trying to unzip it with using tar instead of unzip, and that's just not present on this particular distro of Linux. So that's why that one failed, unfortunately. And as a result, you only get the one instance. You don't get the client in here as well, unfortunately. Any more questions?
I've got just the last part of the error. It does say command bin /unzip cannot handle the archive.
I think it's trying. It's a tar archive, so I think maybe unzip probably doesn't handle tars. Even though we probably named it a zip confusingly, but what a file is named doesn't necessarily mean. Yeah, we've named it TGZ, which I think is. Yeah, it's a tar. We could potentially fix it by, if we go into base, let's do this a lazy way. If we copy this.
If you change the unzip, for instance, to gzip, would that make a difference?
We can maybe just, let's have a look at see which one it's asking for. It's once gtar is the one it looks for. So let's try and install gtar with Ansible and see if that makes it happy. This may very well not work because live debugging is always questionable whether it will go ahead, but let's see if that's happy. And I should have renamed it, so it's going to say installing packages twice. Yeah, no found, so unfortunately it doesn't look like we're going to get that bit to work this evening, but if we had the appropriate dependency install, it would have unzipped for us. We had to change distro at last minute because we were having some networking issues, unfortunately. But it's better to have working networks than a working client, so I'm very grateful for the people behind the scenes that did get this all up and running. Any more? I don't know if the pizza's here or if I'm meant to entertain you for a bit longer. Are we ready for food or are we still waiting?
You could entertain them for another 5 minutes if you can. Nah, but seriously, pizza is ready. But what we do have a tradition here that after we finish, we all take a picture with the presenters.
Ben!
Okay. Anyways, yeah, so just a disclaimer, anybody that does decide to show up, to join us in the picture, that also means you're agreeing for us, for Global Logic to be able to share it on their LinkedIn. So that's the only place they usually post. So, yeah. If there are no more questions, then please anyone that wants a picture, a group picture, to join the group picture, please join Barnaby and Ben together. Thank you.